Hey everybody, this is a video on local and absolute maximum and minimum values. This can be located in the packet of notes that we started last class. A local or relative maximum or minimum value is defined as the greatest or smallest y value in a restricted domain. This is often found where the graph changes direction. Now, the difference with an absolute maximum or minimum, an absolute maximum or minimum is the greatest or smallest y value on the entire domain. Again, this is often found where the graph changes direction or at the endpoints, if there are any. So let's use this example here to talk about absolute max or mins versus relative max or mins. This point here is a relative minimum because in a small neighborhood or a small domain, this is the lowest value in that small neighborhood. So this is called a relative minimum. However, this point down here is the lowest y value on the entire curve. So this is called an absolute minimum because for the entire domain of this function, this is the lowest y value that we get. So we'd say the absolute minimum value is -10. This point here is called a local max or a relative maximum. It's not the greatest value for the entire function, but in a small restricted domain, that is called a local or relative maximum because it has the greatest value in a small neighborhood around that point. Now, because this graph continues forever upwards, there is no absolute maximum because the graph keeps going and going and going forever towards infinity. So for this one, we'd say there is no absolute maximum value. There is, however, an absolute minimum value of -10. All right, let's try a couple examples. Number one, if the function is f of x equals the absolute value of x, find the absolute maximum and minimum values of f of x. I picked a relatively easy function. So if we sketch a graph of the absolute value of x, we would say the absolute minimum value is 0. For this example, there is no absolute maximum because the graph goes on forever in an upwards direction. There's no maximum value we will ever reach. Now let's look at number two. Find the absolute maximum and minimum values. The absolute maximum value for this graph, which has endpoints, the absolute maximum value is here. So we'd say the absolute maximum value, so the function value, is 20. Now, this endpoint is a relative minimum, but the absolute minimum value occurs at this point, endpoint right here. So we would say the absolute minimum value is -3.8. If you look at our final example here, number 3, find the absolute maximum and minimum values. Well, it looks like the exact same graph, except there's an arrowhead on here. So if we're going to do absolute minimums again, the absolute minimum value, which is the smallest y value on the entire domain, is right here. That is the smallest y value. So the absolute minimum value has not changed from the problem we just did. It's still -3.8. But now for this problem, the absolute maximum, there isn't one. because this graph goes forever in an upwards direction, there is no absolute maximum value. This point here, which was an absolute maximum in the previous problem, now this is a relative maximum.